All right. So when you are yesterday, we went through and gave the specific terminology to what we've been doing. So before we were just asking, is it proportional? Is it proportional? And you would say yes, or you would say no. Well, when we were determining if it's proportional, we were always doing that y over x and seeing, okay, does it give us the same value? And when we saw it gave us the same value every single time, let's say it was 15 over 3, which is 5. And let's just say that it was 10 over 2, which was 5. We were like, okay, yeah, since it has the same value every time, it's proportional. That is our constant of proportionality, and it's represented by the letter K. So we were already doing it, and then we gave it its specific name. So this number in this case, where they both gave us that 5 in return, that is our constant proportionality. We were also saying, is it proportional? Yes or no? Well, now we learned, well, when it's proportional, it has a specific equation of y is equal to kx. And x and y represent our x and y's, or our x is our independent variable, and our y is our dependent variable. So sometimes we can use other letters besides x and y, but always say, well, which one affects the other? So like when we talk about later on tickets and costs, well, we can buy any number of tickets we want, but the cost was always going to be reflected upon the number of tickets we buy. If tickets cost $10, then we can't spend $15 because you can't buy half of a ticket. So in that case, our costs would be our dependent and our tickets would be our independent. So that's what we can always ask ourselves. What is one that's dependent on the other? All right. But when we write it as an equation, it's y is equal to kx. Well, in this case, here, if we said identify the constant proportionality, it's 5. Well, our equation then is y is equal to 5x, right? So we were already applying this and using it in questions, but we never gave it its specific names because I wanted us to build our confidence and solve these questions and then be like, okay, now this is the specific name to it. All right, so now I'm going to go through some of these questions that you guys asked for, and I'm going to go through some that you didn't ask for as well, just to kind of make sure if you guys need it, it's there, but you can skip the video as much as you need to. All right, so for 1 through 4, there's two things. One, does it pass through the origin? And two, is it a straight line? Well, here I see it's not a straight line, so it doesn't satisfy that. So I know, no, it's not proportional because it doesn't form a straight line. Even though it goes to the origin, it's not a straight line, so we know it's not proportional. Here, it is a straight line, and it goes to the origin. So this one's yes. And all you would just have to say is that it forms a straight line, and it goes to the origin. That's all we need. When it's a table, we look to see, does it grow at the same rate? So we're looking to see, is y over x the same? So 18 over 3 is equal to 6. 30 over 5 is equal to 6. 48 over 8 is equal to 6. And 72 over 12 is also equal to 6. So since all of our x and our y divided by x's were the same, then yes, this is proportional. And you would say because every y over x was equal to 6. And remember, this rate is our constant of proportionality, or our k, that we just discussed as well. If I look at 4, I don't have to do a single thing. This says when x is 0, y is negative 1. So when x is 0, y is negative 1. That means it does not pass through the origin. So I can say, no, it doesn't pass through the origin because it has the point of 0, negative 1. That right there is actually the best answer you can give because it's showing me you actually know how to apply that and understand what it looks like in the table. Or we can do 4 divided by 1 is 4. 9 divided by 2 is 4.5. And you can also say, no, not every y over x gives us the same value. Therefore, it's not proportional. All right? Doesn't really matter which one, how you want to go about doing it, but both of them are fine. All right? I'm going to also go through this one. When we have a table like this, we can convert all of these into an ordered pair because our ordered pairs are written as x, y. So this is saying when x is 0, y is 0. This one's saying when x is 2, y is 3. This one's saying when x is 4, y is 6. And this last one's saying when x is 6, y is 9. So now I'm just going to go ahead and plot these points. 0, 0, 2, 3, 1, 2, 3, 4, 6, and 1, 2, 3, 4, 5, 6, and 6, 9. Once you do that, On your assessment, you will be expected to use a straight edge. So this is a nice straight line. Mine's not going to be because I can't use a straight edge on the thing that I'm drawing on. It's hard to do that. So you draw your line. And 1C, does it form a line? Yes, it does. So it's perfectly straight. Does it pass through the origin? Well, we knew that already with the table, but it also verified with this. So yes, it is proportional because it passes through the origin and forms a straight line. All right, this next one, I didn't give you the origin number, so you don't really know. We can check our other work that we've done before. 1/1 is equal to 1. 3/2 is equal to 1.5. So I can do that to verify my answer. So I know this isn't going to be, but the directions say for you to plot the point from the table to determine if it's a proportional or not. So we have 1, 1 is here. We have 2, 3. So I'll change. This will be black. This will be blue. This will be green. And this will be red. So 2, 3 is here. 3, 5 is there. And 4, 7 is here. If I were to use a straight edge, I would see that this line does not pass through the origin. So I can verify on my graph, even though it is a straight line, it does not pass through the origin. So this one is no. But we can also check our work with another method if we feel more comfortable with that to verify what we're saying is right or not. All right, for 7 or 10, it's asking if it's proportional. So if it is, that means we can write it as a direct variation of y is equal to kx. So that means that our powers for both of these are 1. So if I ever see one of these variables have a different power than 1, like let's say y is equal to 3x squared, that's not proportional because our x and y are not growing at the same rate. Our x is being squared, or y, we're going to be squaring that x every time. All right, so they have to be that. There's nothing being added or subtracted to it because as we talked about in class, if we start with the number 1 and then we're saying, okay, we're going to add 1 to it, well, this then gives me 2, and that original number got doubled. Well, if we start with 100 and we add 1 to it, we're doing the same thing as the problem before, but this number only increases by 1% now and not double. So adding or subtracting doesn't change every number at the same rate. So if I see anything being added or subtracted, it's not proportional. And then the other thing is both of our x and y's are in our numerator here because I can understand I can write this over 1, I can write these over 1, so they're both in our numerator as well. Here, we have y is equal to 8 over x. Well, one of the things that has to do is it has to pass through the origin. So if I say x is equal to 0, I can substitute that in for 0, and that can help me solve for what y is. But I can't divide by 0. It's undefined. So since we can't actually do that, that means x can never be 0. So if x can never be 0, that means it cannot pass through the origin. So if I ever see x in my denominator, and let's say y is equal to 15 over x, well, once again, x is in our denominator. Therefore, x cannot be 0 in this case. So therefore, it cannot pass through the origin. So this one is no. And also, we cannot write it as a direct variation. What our goal is for each of these as well, if you know how to solve equations and you've already done that, you can try and manipulate your problem to get it to be y is equal to on its own. And if it's not a number times x, then it's not direct variation. Here, it's set equal to y. That's what we want with our problem. And it's 5x, so it's just a number times x. So if I say x is equal to 0, well, y is then equal to 5 times 0. So y is also 0. So that tells me it goes to the origin. And every single value I plug in for x will always get multiplied by 5. Therefore, it is growing at the same rate. So this one is yes. It is written in direct variation form of y equals kx. So that's all you kind of have to say. But you can go through and say it's growing at the same rate and it passes through the origin. And then it does ask for you to identify the constant proportionality. So that's saying what is k equal to? Well, in this case, it's whatever is being multiplied to x. So k is equal to 5. For this one, I see that y is not by itself. It's 6 times y. Well, my direct variation equation is y by itself. So I want to rewrite this to get y isolated. So if we're multiplying 6 by y, to isolate y, we undo that multiplication through division. And just think about this for a second. If I say 12 is equal to 12, and I divide this by 6, well, that is then 2. If I don't divide the other side by 6, 2 doesn't equal 12 anymore. So when we're solving equations, if you haven't learned this already, which we're going to do later on this year, but you should have learned this last year, if solving basic equations, 12 divided by 6, what we do to one side, we have to do to the other. So 2 is then equal to 2. So for here, if I want to see if it's direct variation, I can just isolate my y and divide by 6. So y is then equal to 4x. Now I see it's written in my direct variation form. I know it's growing at the same rate because x is always being multiplied by 4. And if I plug in 0, it's going to pass through the origin as well. So that one we know works. Here, it's being added. So I can say once we have addition, it's not proportional anymore. Or I can plug in if x is equal to 0, y is equal to negative 2 times 0 plus 1. Well, 0 times anything is 0, and 0 plus 1 is 1. So that means when x is 0, y is 1. So it does not pass through the origin. It is not proportional. All right, for these ones, there's a difference. It says given that it is proportional. So we're not testing it. That means every single value y and x are growing at the same rate. Once again, I don't write y or x, so I do write t and c and tickets and costs. So think about which one is dependent on the other. However many tickets we buy will determine the cost. So that means this one is our independent, this one is our dependent, and that means this is considered our y value and this is considered our x. So if I want to find a constant proportionality, it's y over x, but in this case, it's our cost over the number of tickets we have. And 140 divided by 4 is equal to 35. So that means k is equal to 35. It does ask for you to explain what it means in the context of the problem. So what does that 35 mean? It's saying how much each ticket costs. And now to write this as an equation, we know is y is equal to kx. Well, this 35 is our constant proportionality, which is our k. So y is equal to 35x. Or I guess what I should be writing is c, or cost, is equal to 35t, which is our tickets, how many tickets we're buying. How much would it cost if we bought 37 tickets or tickets for 37 people? And it says, some of you are like, oh, is that 37 tickets? It says a ticket for 37 people. So that's singular. So each person's getting one. So our cost is equal to our 35, which we know represent the cost of the ticket, times 37, which 35 times 37 is equal to 1,295. So our cost is 1,295. All right. The next one says how many tickets would cost $805. So 805 is equal to 35 times t. So if we want to figure out how many tickets that is, we can divide the cost by the how much each ticket costs. And 805 divided by 35 is 23. So that means that we would have bought 23 tickets. All right. Then the last one. Nurses, doctors, and other types of caregivers often dispense medications. In many cases, the amount of medication depends on the weight of the person taking the medication. The graph shows the dosage of medication for the various weights. What is a constant proportionality? Explain what it means in the context of this problem. So we know our constant proportionality is y over x. We see it's proportional. So I'm just going to pick one of these points. And it's 10 and 250. This is my x, and this is my y. So 250 over 10 is equal to 25. So my k is 25. What it means in the context of our problem is that for every kilogram that a person weighs, we need to give them 25 milligrams of the dosage of the medicine. All right? Write an equation. Well, we know it's y is equal to kx. We just said k is 25, so y is equal to 25x. What dosage is needed for someone who weighs 100 kilograms? Well, the dosage, in this case, we can say y is equal to 25 if they weigh 100. We multiply that. That means that we would need 2,500 milligrams of the medicine. And the last one, how much does a patient weigh if they had a dosage of 1,750? So 1,750 milligrams is equal to 25x. And then if we do 1,750 divided by 25, x is then equal to 70. That means that the person would have to weigh 70 kilograms. All right. I went through this kind of quickly. This test is after your lunch. So if you want to get some extra help, come and see me during lunch. Just make sure you email me first.